Welcome to Getting Started with Fortinet Zero Trust Network Access, or ZTNA. In this video, we'll discuss the technical components of the ZTNA solution and review the configuration steps necessary to provide secure remote access to a web application server without the use of dial-up VPN. Why are many organizations moving to Zero Trust Network Access over dial-up VPN? The user experience is simplified. Whether on the corporate network or at a remote location, the user experience remains virtually the same. There's greater security provided through granular application access that limits the attack surface compared to VPN solutions. With support for SaaS applications, ZTNA can assist with the journey to the cloud by providing visibility, posture checking, and added security when accessing cloud applications. The ZTNA solution is a way of defining several methods to assess a device and user before they are trusted to access protected applications. The access to applications and data is automatic and secure through encrypted connections without the use of a VPN solution. The Zero Trust assessments are continuous so that if the endpoint posture changes, access to the applications will be denied or granted dynamically. How does ZTNA work? Device certificates that are automatically installed by FortiClient Endpoint Management Server during the device onboarding are used to confirm a device's identity. User identity is verified using a variety of authentication solutions. Multi-factor authentication is recommended with the use of FortiToken or by third-party identity providers through SAML integration. ZTNA rules are also configured to assess the posture of the device, which can include domain membership, vulnerability status, and security software compliance, and more. The connection from the device to protected applications is encrypted whether at a corporate or remote location without the use of VPN. And of course, all communication is logged for reporting and analysis. Let's look at our office user Jennifer's workflow for connecting to protected applications in the local data center, public cloud, or those hosted by software as a service. Jennifer is using a company-issued laptop with the FortiClient ZTNA agent installed. Once connected to the FortiClient Endpoint Management Server, or EMS, the device is automatically issued a certificate. The logged-in user is verified, and the posture of the endpoint is checked. EMS transmits this data to the FortiGate, acting as the Zero Trust Access Gateway. Jennifer and her device are then allowed access to the application assuming they have passed each of the Zero Trust posture checks. Remember, these Zero Trust checks are continuous so that if the posture of the device changes, access can be dynamically denied until the problem is remediated. Once remediated, the device is then allowed access again automatically. Like our office worker Jennifer, Tom needs access to protected applications while he's working remotely. The process for connecting to his applications remains the same as Jennifer's. Tom is very pleased with the ability to directly access these applications without the use of dial-up VPN, especially at hotels where the on-site captive portals were sometimes troublesome. Next, let's take a look at the configuration steps to get started with ZTNA. Getting started with ZTNA is very straightforward, especially if you are migrating from dial-up VPN. Current versions of FortiOS, FortiClient EMS, and FortiClient already contain the necessary features. We just need a few configuration steps to begin. We'll start with the FortiGate, configuring a ZTNA access proxy and firewall policy to provide access to a web application server. In FortiOS, let's take a look at the first step that creates and maps a virtual IP to the location of the protected web application. Under Policy and Objects, we navigate to ZTNA. Here we have two access proxies configured, but in this demonstration we are focused on getting started with just a simple web application. First, we've provided a simple descriptive name, in this case ZTNA Web Server. We assign an internet-facing interface and provide an internet IP address. Ours is a simulated IP in this lab. We also configure a port to be used. We'll skip over the SAML authentication configuration for this demonstration. Next, we've selected a trusted certificate to secure the encrypted communication. In this case, we're using a wildcard SSL certificate that is trusted by our managed endpoints. Now we'll configure the server service mapping to tell the access proxy the location of the protected web server. We're providing access via HTTPS for web browser-based applications and can leave these settings default for our purposes. Next, we'll configure the location of our protected server. Here we provide the IP address, or fully qualified domain names are supported as well, along with the port number of the web application. Once the configuration is saved, our ZTNA access proxy is created. Next, we'll configure a ZTNA firewall policy to control access to our proxy. Before we configure our firewall policy, let's take a look at ZTNA tags that have been brought over from our Fabric integration with the FortiClient Endpoint Management Server. We see a few ZTNA rules have been configured in EMS to check the posture of our managed endpoints. FortiClient is scanning for vulnerabilities, and per the ZTNA rule, any endpoints with critical vulnerabilities will be tagged. These tags can then be used in firewall policies. Another ZTNA rule has been configured to determine that the connecting device is a device logged into a specific Active Directory domain, and that the user is part of the domain users group. These tags can be used in firewall policies to allow or deny access as appropriate. Before creating our firewall policy, let's also understand more about how FortiClient EMS connects to the security fabric to provide FortiOS more intelligence about an endpoint's posture. Under Security Fabric and Fabric Connectors, we can see the connection to our EMS server. Through this connector, EMS provides information that is used to prove the trust of the devices connected to the network. The threat feed is used to enhance zero trust capabilities by detecting compromised endpoints using the FortiGuard outbreak detection service in EMS. And then the synchronization of firewall addresses populates dynamic address lists and also creates ZTNA tags. Now let's move on to the firewall policy and take a look at a simple ZTNA policy to control access to our protected web server. In FortiOS 7.2.5 and beyond, we can configure simple ZTNA policies in the same place that we create any other firewall policy, under Policy and Objects, then Firewall Policy. We've created a policy called ZTNA Access. The policy type is ZTNA. Our source can be configured as all, and then by default FortiOS will only allow an endpoint with the proper ZTNA device certificate to pass through. But in this case, we've added on another factor of authentication using Active Directory. We've added a ZTNA tag that requires endpoints to be registered to our EMS server before FortiOS will allow access. Because this is a ZTNA firewall policy, the ZTNA server is the destination, which is our web server ZTNA access proxy. We can configure a schedule to control when the application is available, and we can choose any of our security profiles for added protection. Once the policy is saved, our remote users, like Tom Smith, can now access the web application server without the use of dial-up VPN. Like our allow policy, we can also create a policy that blocks access to our protected web application server based on the posture of the endpoint. We've created a policy called ZTNA Deny Access and added the tag for critical vulnerabilities. This will allow us to dynamically block access to devices with critical vulnerabilities. We'll leave the policy disabled until we've alerted and educated our end users through our Information Security Awareness program and done some analysis through our patch management process. Next, let's take a look at the second component in the ZTNA solution, FortiClient Endpoint Management Server. EMS manages the certificates that provide a level of trust in the ZTNA solution and manages the FortiClient ZTNA agent and related features. This is the same agent and license that is used for dial-up VPN, making it very easy to migrate to ZTNA. FortiClient provides detailed device telemetry to EMS that is then relayed to the Security Fabric through the EMS Fabric connector. In EMS, we have real-time dashboards that provide information about the status of the FortiClient endpoints. We can also check the configuration of Security Fabric devices that integrate with EMS. Under Administration and Fabric devices, we have authorized the connection from our FortiGate ZTNA gateway. With this Fabric connection, EMS is now sending authorized device identity information to FortiOS for use in firewall ZTNA policies. There are several options here, including outbreak tags and manual classification tags. By default, only zero trust tags are shared. Let's take a look at the information that is collected about an endpoint after it is onboarded to EMS. Drilling into Tom Smith's device, we can see a wealth of information about Tom and his device. This includes the ZTNA serial number, which is derived from the device certificate issued to Tom's device when registering to EMS. This serial number is passed on to FortiOS and used in verifying the identity of Tom's device. In EMS, we also configure posture checking using ZTNA rules. These rules create tags that are delivered to the FortiGate and are dynamically updated when a device's posture changes. Here we've created two ZTNA rules that will tag devices based on domain membership and vulnerability status. There are many ZTNA rules to choose from that can be used to ensure device posture, including security software compliance and others. The rules are specific to the supported operating systems. We can also see what devices have been tagged by specific rules in the Zero Trust Tag Monitor. Here we see that Tom's device has a critical vulnerability and that Tom is part of the domain users group. All endpoints are tagged with the low classification tag. Classification tags are manual tags that can be used in special circumstances to identify a small group of unique devices. The third part of the ZTNA solution is the FortiClient ZTNA agent. FortiClient executes the managed configuration from EMS. It automatically installs the certificate used for ZTNA, checks for operating system and application vulnerabilities, and discovers the device's hardware and software information. FortiClient also checks the status of security software on the device and delivers the logged-in user information back to EMS. All of this information can be used to decide the trust level of the device and whether or not it should be allowed access to the protected applications and data. Let's now join our remote worker Tom Smith as he connects to his web application server without the use of dial-up VPN. On Tom's device, we can open the FortiClient console and quickly check the status of the connection to EMS using the Zero Trust Telemetry tab. We can also see what Zero Trust rules have matched on Tom's device by clicking on his username and looking in the bottom right of the console. We already saw this status in EMS, but it can be optionally made visible here in the FortiClient console as well. We can look at more information about the critical vulnerability that FortiClient has identified by looking at the Vulnerability Scan tab. If we have the ZTNA Deny Access policy enabled on the FortiGate, Tom will be blocked from the web application server until the vulnerability was remediated. Let's watch as Tom connects to the web application server. Tom uses the same web browser shortcut that he uses on the corporate network even though he's working from a remote location. Tom is presented with a certificate prompt that he accepts, which is then passed to the FortiGate. The FortiGate checks the certificate to be sure it matches information provided from EMS. Once the device has passed the device identity check, Tom is presented with an authentication prompt. Tom knows to type in his Active Directory user ID and password, just as he did with VPN. Tom is then granted access to the web application server through the new ZTNA Access proxy. In summary, there are only a few steps to get started with Fortinet ZTNA, especially when migrating from SSL VPN. On the FortiGate, create a ZTNA Access proxy and a ZTNA firewall policy to allow access. If not already connected, enable the EMS Fabric connector and authorize it on the EMS server. Be sure the FortiClient ZTNA agent is registered to EMS. After getting started, add on additional security profiles, multi-factor authentication, and additional ZTNA posture checks. Thanks for watching the Getting Started with ZTNA demonstration video. For more information including getting started, deployment, and administration guides, visit docs.fortinet.com/ZTNA.